Your plan to relocate the electrical service and upgrade it to 400 amps is generally sound, but there are a few points to consider. Firstly, consider the service disconnect location. According to the National Electrical Code, the service disconnect must be readily accessible and located outside or at the point of entry to the building. In this case, the service disconnect at 200 amps will be located in the garage, which may not be considered a point of entry. You may need to install a disconnect at the point of entry to the building, for example, near the garage door, in addition to the one in the garage. Secondly, think about the feeder size and type. Since you are upgrading the service to 400 amps, you will need to use larger feeder cables, for example, 4/0 aluminum or 3/0 copper, to connect the service disconnect to the main panel in the basement. The feeder cables must be sized according to the load calculations for the building. Thirdly, when it comes to SER cable is not typically used for feeder runs in residential applications. It is more commonly used for branch circuits. Consider using THHN or XHHW cable with appropriate conduit for the feeder run. Fourthly, regarding load balancing, with a 400 amp service, it is important to balance the load between the two 200 amp panels. This ensures that each panel is not overloaded and that the service capacity is utilized efficiently. Fifthly, permits and inspections are critical. Make sure to obtain the necessary permits and have your electrical work inspected by a qualified inspector before energizing the system. Consult with a licensed electrician to ensure that your plant complies with all applicable codes and regulations and that the electrical system meets the specific requirements of your home. The National Electrical Code, or NEC, is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. It is essential to adhere to the NEC guidelines to prevent electrical hazards and ensure the safety of people and property. When planning an electrical service upgrade to 400 amps, it is important to consider several factors, including the service disconnect location, feeder size and type, SER cable usage, load balancing, and permits and inspections. The service disconnect is the main switch that shuts off power to the building. The NEC requires that the service disconnect be readily accessible and located either outside the building or at the point where the service conductors enter the building. This allows emergency responders to quickly disconnect power in case of a fire or other hazardous situation. If the service disconnect is located inside the garage, it may not be considered readily accessible, especially if the garage is locked or obstructed. In this case, an additional disconnect may be required at the point of entry, such as near the garage door. The feeder cables are the conductors that carry power from the service disconnect to the main panel in the basement. When upgrading to a 400 amp service, it is essential to use larger feeder cables to handle the increased current. The size of the feeder cables must be determined based on the load calculations for the building. The load calculation takes into account the total amount of power that is expected to be used by all the electrical devices and appliances in the building. The NEC provides tables that specify the minimum size of feeder cables for various load requirements. Common feeder cable sizes for a 400 amp service include 4/0 aluminum or 3/0 copper. It is important to choose the appropriate cable size to prevent overheating and voltage drop. SER cable, which stands for Service Entrance Cable, is a type of cable that is commonly used for branch circuits in residential applications. Branch circuits are the circuits that supply power to individual outlets, lights, and appliances. SER cable is not typically used for feeder runs, which are the main conductors that carry power from the service disconnect to the main panel. Feeder runs typically require a more robust type of cable that is protected by a conduit. Conduit is a rigid or flexible tube that protects the cable from physical damage and environmental factors. Common types of cable used for feeder runs include THHN, which stands for thermoplastic high heat resistant nylon coated, and XHHW, which stands for cross-linked polyethylene high heat resistant water resistant. These cables are typically installed in conduit to provide added protection. Load balancing is an important consideration when upgrading to a 400 amp service. With a 400 amp service, the power is typically distributed between two 200 amp panels. It is essential to balance the load between the two panels to ensure that each panel is not overloaded. An overloaded panel can cause circuit breakers to trip, which can disrupt power to the building. To balance the load, it is important to distribute the electrical devices and appliances evenly between the two panels. This may require some planning and careful consideration of the power requirements of each device and appliance. Permits and inspections are required for most electrical work, including service upgrades. Before starting any electrical work, it is important to obtain the necessary permits from the local building department. The permit process ensures that the electrical work is performed in accordance with the NEC and other applicable codes. Once the electrical work is completed, it must be inspected by a qualified inspector. The inspector will verify that the work was performed correctly and that it meets all the applicable codes and regulations. Obtaining permits and inspections is essential to ensure the safety and legality of the electrical work. Consulting with a licensed electrician is highly recommended when planning an electrical service upgrade. A licensed electrician has the knowledge and experience to ensure that the electrical work is performed safely and correctly. The electrician can help with load calculations, cable sizing, conduit installation, load balancing, and obtaining permits and inspections. The electrician can also identify any potential problems or hazards and recommend solutions. The cost of an electrical service upgrade can vary depending on several factors, including the size of the service, the complexity of the installation, and the location of the building. It is important to obtain multiple quotes from different electricians to compare prices and services. When comparing quotes, it is important to consider the electrician's experience, qualifications, and insurance coverage. It is also important to ask for references and check online reviews. Choosing a qualified and reputable electrician is essential to ensure that the electrical work is performed safely and correctly. Some additional considerations when upgrading to a 400 amp service include the following. Firstly, grounding and bonding. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect against electric shock. Bonding connects all the metal parts of the electrical system together, which helps to equalize the voltage and prevent stray currents. Secondly, surge protection. Surge protection devices, or SPDs, can protect electronic devices from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. SPD are typically installed at the service entrance and at individual panels. Thirdly, arc fault circuit interrupters, or FSIs, are circuit breakers that are designed to detect arc faults. Arc faults are dangerous electrical conditions that can cause fires. FSIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. Fourthly, ground fault circuit interrupters, or GFCIs, are circuit breakers that are designed to detect ground faults. Ground faults occur when electricity flows through an unintended path to ground. GFCIs are required in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor areas. Upgrading to a 400 amp electrical service can provide several benefits, including increased power capacity, improved reliability, and enhanced safety. However, it is important to plan the upgrade carefully and to follow all applicable codes and regulations. Consulting with a licensed electrician is highly recommended to ensure that the upgrade is performed safely and correctly. In addition to the NEC, local codes and regulations may also apply to electrical work. It is important to check with the local building department to determine the specific requirements in your area. Local codes may have additional requirements for service disconnect location, feeder size, cable type, grounding, bonding, surge protection of size, and GFCIs. Adhering to local codes is essential to ensure the safety and legality of the electrical work. When selecting electrical equipment, it is important to choose products that are listed by a nationally recognized testing laboratory, or NRTL, such as Underwriters Laboratories, Oral. NRTLs test electrical equipment to ensure that it meets safety standards. Using listed equipment helps to ensure that the electrical system is safe and reliable. The NEC provides detailed requirements for the installation of electrical equipment. These requirements cover topics such as wiring methods, overcurrent protection, grounding, bonding, and clearances. Following the NEC installation requirements is essential to ensure the safety and performance of the electrical system. When working with electricity, it is important to take safety precautions to protect yourself from electric shock. Always turn off the power before working on any electrical equipment. Use insulated tools and wear rubber gloves and shoes. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working with electricity, hire a qualified electrician. Electricity can be dangerous, and it is important to take safety precautions to avoid injury. The information provided in this narration is for general guidance only and should not be considered a substitute for professional advice. Electrical work should only be performed by qualified individuals who are familiar with the NEC and other applicable codes and regulations. The narrator and publisher disclaim any liability for any damages or injuries that may result from the use of this information. Always consult with a licensed electrician before starting any electrical work. The National Electrical Code is updated every 3 years. It is important to use the latest edition of the NEC when performing electrical work. The NEC is available for purchase from the National Fire Protection Association, or NFPA. The NFPA also offers training courses on the NEC. Staying up to date on the latest edition of the NEC is essential for electrical professionals. Electrical codes and regulations are constantly evolving to reflect new technologies and safety concerns. It is important to stay informed about these changes to ensure that electrical work is performed safely and correctly. There are many resources available to help you stay informed about electrical codes and regulations, including the NEC, local building departments, and professional organizations. Taking the time to educate yourself about electrical codes and regulations can help you to avoid costly mistakes and ensure the safety of your electrical system. When planning an electrical service upgrade, it is important to consider the long-term needs of the building. Consider the potential for future expansion or the addition of new electrical devices and appliances. It may be wise to upgrade to a larger service than is currently required to accommodate future needs. This can save time and money in the long run. When upgrading an electrical service, it is important to properly dispose of any old electrical equipment. Old electrical equipment may contain hazardous materials such as lead and mercury. It is important to dispose of these materials in accordance with local regulations. Many communities offer recycling programs for old electrical equipment. Contact your local waste management department for more information. Upgrading an electrical service can be a complex and challenging project. However, by planning carefully, following all applicable codes and regulations, and consulting with a licensed electrician, you can ensure that the upgrade is performed safely and correctly. A properly upgraded electrical service can provide increased power capacity, improved reliability, and enhanced safety for your home or business. Remember to always prioritize safety when working with electricity. If you are not comfortable performing electrical work yourself, hire a qualified electrician. Electricity can be dangerous, and it is important to take precautions to avoid injury. By following these guidelines, you can ensure that your electrical service upgrade is a success. These considerations offer a comprehensive approach to upgrading electrical service to 400 amps, emphasizing safety, compliance, and future-proofing.